An inverse function is another function that will reverse the effect of the first function. The inverse of a function f is written as f negative 1. Function f convert x into y, whereas the inverse function of f convert y back to x. The domain of f inverse is the range of f, and the range of f inverse is the domain of f. X is the domain for the function f and y is the range of function y. On the other hand, y is the domain for function of f inverse and x is the range for f inverse. The inverse of a 1-1 mapping is 1-1 mapping. However, the inverse of a many-1 mapping would be 1-many, and that is not a function. Thus, only 1-1 functions have inverses. To determine whether the graph of a function has an inverse function, we carry out the horizontal line test. We draw a horizontal line that cut through the graph. If it only cut through one intersection point, then f has an inverse function. If it cut through two or more points, f does not have an inverse function. Note that f inverse is not the reciprocal of f. The symbol f here refers to function and not an index. In all cases, f of f inverse is equal to f inverse of f and is equal to x. F of x equal to x is known as identity function. Let's look at the example 1.5.1. Find the inverse function for the following. For the first example, we have f of x equal to x plus 3 over 2x minus 1. X is our variable. In order to find the inverse function of f, we let the inverse function of f equal to y. X equal to f of y. Substitute y into the function f, we have y plus 3 over 2y minus 1. For the next step, we are going to make y the subject. Therefore, we multiply both sides with 2y minus 1. X multiplied with 2y minus 1 equal to y plus 3. Then we expand the bracket. We have 2xy minus x equal to y plus 3. We collect all the terms with y at one side and all the terms without y at the other side. 2xy minus y equal to 3 plus x. Factorize the y bracket 2x minus 1 equal to 3 plus x. Divide both sides with 2x minus 1. We get y equal to 3 plus x over 2x minus 1. And lastly, what is our y? Our y is f inverse. Substitute y equal to f inverse, we get f inverse of x equal to 3 plus x over 2x minus 1. And our x cannot be 1 over 2. For the second example, we have g of x equal to 5 minus 2x over x plus 4. X is the variable. Similar to the first example, to find the inverse of function g, we let the inverse of function g equal to y. Hence, we have x equal to g of y. Substitute y into the function g, we have 5 minus 2y over y plus 4. Then we want to make y the subject, so we multiply both sides with y plus 4. We expand the bracket. Xy plus 4x equal to 5 minus 2y. Group the y together. Xy plus 2y equal to 5 minus 4x. Factorize the y. and divide both sides with x plus 2. And lastly, substitute back y into inverse of g. We get g inverse equal to 5 minus 4x over x plus 2, where our x cannot equal to 2. Basically, to find the inverse function, first step, we let the inverse of the function equal to y. Then we make y the subject. And lastly, substitute y equal to h inverse back to the equation. Example 1.5.2. Given function f such that x is converted into 6x plus m, and inverse function of f is 2nx minus 1 over 3. Find the value of m and of n. Here we have two pieces of information. F of x equal to 6x plus m, and inverse function of f is equal to 2nx minus 1 over 3. We are asked to find the value of m and n. Since we are given the inverse function, we find our own inverse function of f and then compare our answer with the given equation. Let inverse function of x equal to y, x equal to f of y. Substitute y into the function f, we have 6y plus m. Make y the subject, we have 6y equal to x minus m, y equal to x minus m over 6. Substitute back y equal to inverse of f, we get f inverse of x is equal to x minus m over 6. To make it easier for us to compare, I will separate the fraction into 1 over 6x minus m over 6. This is what we get for inverse of f, and this is what is given. As comparison, 2n is equal to 1 over 6. N will be 1 over 12. Negative 1 over 3 is equal to negative m over 6. Therefore, m is equal to negative 1 over 3 multiplied with negative 6. We will get positive 2. Example 1.5.3. Function f and g are defined as function f such that x is converted into x squared and function g such that x is converted into 2x plus 5. Find the following. We have f of x is equal to x squared and g of x is equal to 2x plus 5. For the first one, we are asked to find function fg. This is just a composite function of fg. F of gx is equal to gx squared. Substitute the gx, we have 2x plus 5 square. Expand the bracket, we have 4x squared plus 20x plus 25. Fgx is equal to 4x squared plus 20x plus 25. And x is the variable. For the second one, we are asked to find the inverse function of f. Let the inverse function of f equal to y, x equal to f of y, which is y squared. Then we have y equal to square root of x. Hence, we have f inverse of x is square root x. For the third one, we are asked to find the inverse function of g. We let the inverse function of gx equal to z. X equal to g of z. Substitute the z into the function g. We have 2z plus 5. Make z the subject. 2z equal to x minus 5. Z equal to x minus 5 over 2. And hence, inverse function of g is equal to x minus 5 over 2. For the fourth one, we are asked to find f inverse of g inverse x. Basically, we substitute g inverse of x into the function f inverse. We need to use the value that we get from the second example, square root of g inverse x. Substitute g inverse into the function. We have square root of x minus 5 over 2. Number 5, we are asked to find g inverse of f inverse x. We substitute the f inverse into the g inverse. F inverse minus 5 over 2. Substitute the value, we have square root of x minus 5 over 2. Six, we have to find f inverse g inverse of fgx. So the function f inverse g inverse we already obtained in number 4. We are going to substitute fg into number 4. Square root of fgx minus 5 over 2. Then we substitute fgx into the function. Fgx is obtained in number 1. So we have 4x squared plus 20x plus 25 minus 5 over 2. We simplify the function. 4x squared plus 20x plus 20 over 2. And divide all the terms with 2. We have square root of 2x squared plus 10x plus 10. Lastly, number 7, we are asked to find g inverse f inverse of fgx. G inverse f inverse is found in number 5. So we substitute the fg of number 1 into number 5. Square root fgx minus 5 over 2, which is equal to square root 4x squared plus 20x plus 25 minus 5 over 2. For the next section, we will discuss more questions on inverse function. You may try the questions and see how much you understand about this topic. In the next video, a detailed solution will be given. So good luck in trying the questions. See you again in the next video.